Hey everybody, thank you for joining us today. So you may remember that a few weeks back we had an episode where we first talked about AWS RoboMaker and we showed you how to start your very first robotic Hello World app. And today we're here with a few other devs from the same organization, and we're going to show you how to avoid getting your robot hacked. We're going to learn about different security features in ROS. So I'm Alejandra, I work here in developer relations at AWS, and I'm going to go ahead and let my other guests here go ahead and introduce themselves.
Hi everyone, I'm Abby. I'm a software engineer on the AWS RoboMaker team.
And I'm Ryan. I'm also a software developer on the AWS RoboMaker team.
Okay, so before we started and we were preparing for the show, we were also talking about how each one of us kind of got curious about robotics and how we first got into it. I am very new to this. I just got into it because AWS RoboMaker was launched and I wanted to learn more about robotics. Ever since I was a kid, I was always curious, but I never really got the opportunity until now. And I thought it would be really cool if Ryan and Abby told us a little bit about how they got into robotics. So Abby, how did you get into it?
So I first learned about the existence of surgical robots through a friend of mine. Surgical robots are robots that enhance surgeons' capabilities to perform surgeries. I've always wanted to help to build a better world, and I've made the decision to do so by studying robotics when I was in college. I'm really glad that I'm working on a team that focuses on providing a better development platform for roboticists, and I think that the work we do here is really accelerating the development of robots.
What about you, Ryan?
I was returning to Amazon from an internship and trying to decide which team I wanted to join. I got a call from a manager on the RoboMaker team before it had been announced, and he said, "I'm working on this project. I can't tell you what it is, but it's going to be awesome." And I was like, I'm in. So even though I had minimal background in robotics, luckily Ross made it really easy to get started and dig in.
So basically, Abby, you're a genius that wants to make the world a better place, and Ryan, you were like thrown into an adventure of your life, huh?
Yep.
Awesome, really cool. Okay, well, we wanted to also make one last introduction. Bob. This is Bob. Where does Bob live, Ryan?
He lives in the AWS RoboMaker lab.
Do you think he has friends down there? Is he alone?
He's got lots of robotics friends down there.
All right, so he's not too lonely.
Life. Yeah.
He has a happy life. Okay, so we're going to be doing some really cool stuff, and we're going to show you how to avoid getting Bob hacked. And it's going to be a lot of fun. We're also going to talk to you a little bit about some of the open source contributions that the RoboMaker development team has been doing here. A lot of the work that they're doing toward ROS 2 actually is very related to what we're talking today about security and robotic development. So guys, do you want to tell us a little bit about that?
Yeah, so our team in AWS RoboMaker specifically works on open source contributions. You can find some of those in our AWS-Robotics GitHub organization. Here you'll find some ROS 1 nodes that interact with AWS cloud services like Amazon Kinesis, so that you can stream video from your robot into the cloud, or Amazon Lex, so that you can build chatbots to run on your robot. You'll also find some sample applications that use these nodes and work with AWS RoboMaker. You'll also find some of our contributions to core ROS 2 libraries. You'll find these in the ROS 2 GitHub organization, which is owned by the Open Source Robotics Foundation, the foundation that manages the development of ROS 2, which we'll be using today.
Awesome. Okay. So Abby, Ryan, before we got on here, you guys told me a lot about your work that you've been doing in contributing to ROS 2 and some of the differences between features that ROS 2 has that ROS 1 didn't have, and why you're so excited about the promotion of ROS 2. Why don't you guys share with the audience a little bit of some of those reasons about why we're so excited about ROS 2?
Yeah, sure. I will talk about 3 advantages that ROS 2 has over ROS 1 that are relevant to today's episode. There are other advantages out there, and then I encourage you to check it out online. The first one I want to talk about is that ROS 2 is officially supported on 3 major platforms. It supports Ubuntu Linux, Mac OS, and Windows, whereas ROS 1 is only officially supported on Ubuntu Linux. The second advantage is that ROS 2 uses C++ 11 and 14 with plans to use C++ 17. ROS 1 is mostly written in C++ 03 and earlier, so overall ROS 2 makes better use of features and APIs that newer versions of C++ offer. And the third one has to do with the ROS 2 with the middleware that ROS2 uses. So ROS1 uses a custom central discovery mechanism and a custom transport protocol. Think about adding a new feature in a customized code base. Every time you want to add a new feature, that means your code has to be customized to work for your code base. And so this is exactly one of the disadvantages of using ROS1 is that it adds a lot more code to maintain. Yeah, and
Nobody wants that.
no.
No.
So ROS2 uses DDS, which stands for Data Distributed Services. It's an end-to-end middleware that provides subscribe, publish transport protocols similar to what ROS1 has. The differences are DDS has concrete specifications, and that there are different DDS vendors that have already followed the specifications for their DDS implementations, which allows for reuse of code. On top of all that, there are the use of DDS in ROS2 enables ROS2 to provide quality of service, which improves communication over different networks, and also it provides DDS layer security.
So to recap, it sounds like you're saying that there's three main reasons why we're currently excited about ROS2. Number one being the awesome multi-platform support that it has for major things like Linux, OS, and Windows. Then the second reason being that ROS1 was based on much earlier versions of C++, and then ROS2 is based on later versions. And as we all know, the latest and greatest is what we always want. And then number three, the middleware, right?
Yeah.
Awesome. Okay, cool. So let's go ahead and, get a little bit more into the meat of what we're going to be doing today. Ryan, how would you explain what we're going to be demonstrating to the audience today? What are we doing today for our demo?
Yeah, so today we have Bob, the Turtlebot 3 from Robotis, and we'll be running the latest release of ROS2 Crystal. So what we have set up here is we have a node running on the Turtlebot 3 on the Raspberry Pi that's going to be controlling the Raspberry Pi, and then we'll be running a teleop node on our laptop. In this case, the teleop node is allowing us to send commands to the Turtlebot. So as Abby was mentioning, ROS1 and ROS2 are both publisher-subscriber frameworks. This is a distributed architecture where made up of individual nodes that each take care of a specific task. They then talk to each other over topics. They can subscribe to a topic to get information from it, or publish it to release information to other nodes. In this case, our teleop node will be publishing velocity commands over the command velocity topic to the Turtlebot 3.
And it's such a cool name for a node, isn't it? Teleop node.
Yeah, it makes it sound really fancy.
Yes.
Okay, so what we've already set up our Turtlebot 3 with the node running there. So now all we need to do is start up our teleop script. So we're going to launch that here. And now we can send commands to our robot and see that it is moving.
There goes Bob.
Oh, stop. Okay, there we go. So now we've got them stopped. Okay, so that was really easy to get launched and set up, right? We didn't have that much setup to do. We just had to launch a node on our computer and launch a node on that, on the Turtlebot, on Bob. And that's because DDS managed all of the communication setup between the two nodes. When we launch a new node, it goes through a discovery protocol to discover which other nodes are on the network and figure out which topics and that they're publishing and subscribing to, and then set up the communication between them. This was awesome in our case because it was super easy to set up a node and start communicating with our robot. However, this can cause issues because it's super easy for anyone else who's on our network to also start up their own node and start talking with Bob.
Right.
So you can imagine that this is something you might not want to do, to let anyone start sending commands to your robot.
No, we don't want just anyone talking to Bob.
No,
of course not.
Yeah. So now Abby's going to show us how we can stop just anybody from talking to Bob.
Awesome. All right, Abby, show us how it works.
Okay, so I'm gonna kill this node here. I can figure out, okay. Now, I would like to show that the nodes are currently running in our system. So if I do a ROS2 node list, you can see that there are, that node's not dead. So we're gonna kill that real quick. I'm just gonna kill the 655. Okay.
Maybe the Python 3.
Or maybe the Python 3. Oh, no, killed the other one. So I want to clear the environment first and make sure that the nodes that are running in the system there's just only one node running. So we do that. This is okay. Let's see if we have anything running here. Okay, so we're running into a weird issue that the nodes should, the teleop keyboard node should be dead, but it's not. But let's let me see if I can run that in a different environment.
There's nothing more fun than troubleshooting when you're live, is there? Oh, yeah. I have full confidence in you, Abby.
Okay. What we can do is, okay, here. I'm going to actually start a new Docker container. So what I'm doing is we've prepared a Docker container that we've installed ROS2 in it, and then I think we're running into some technical issues with that. So I'm abandoning the one that Ryan just used, and I'm creating a new one. So let me stop this one. Actually, yeah, let me stop this one once. 152 v3 14 527 5D. Okay, so I'm going to run a new Docker container that has ROS2 in it. And we want to make sure that it's connected to the network host. And here we go. Okay, so now if I do ROS2 node list, okay, sorry. So I'm just going to source the workspace. This is where all the binaries are. So we're making sure that that we can find all the binaries. And we're doing a local setup. This is what you would do if after you've built all the ROS2 core packages. And we've also pre-built all the Turtlebot packages that we need to use today to save us time because it takes very long. Now we're ready to run the command again.
All right.
Now you can see there's only one node running.
Yay, success!
It's really supposed to be one node running because that's the agent running on the Turtlebot, listening to all the commands that we send from our laptop in our Docker container. And now, so I'm going to start off by talking about the tool that I'll be using today. It's called sros2. It's also an open source project, and it provides a set of tools that we're going to use today to generate security files in our ROS2 environment. And it supports Windows. It supports, I think, Mac as well. I haven't tried them though, but if you're interested, you can check them out. Okay, so we're going to go back to our environment. And what I'm going to do is, so there are two steps involved when you want to enable security in ROS2. The first one is that you want to build all of your ROS2 core packages with an additional CMake flag. So we've already pre-built.
So what is a CMake flag?
It's just like a flag. Instead of just a CMake flag, like a argument that you pass in. Yeah. So I have it here. I'm not actually going to run it, but I would like to show you guys how you would do it if you would like to enable security. Okay, there you go. So I'm put it here. This is what you would run, cocon build, and then this is the CMake flag that you want to pass in if you want to enable security. So that's step one, and we've already done that today for today's episode. And the second step is that we want to declare 4 environment variables. the first two, so I'm going to start off with the two that are pretty self-explanatory. So we have security, okay, this is not the one I want. We're going to start off with raw security enable, so we make it true, and then the other one is...
ROS security strategy?
Yes. This one. It's hard to figure out. Okay, not that one. Here and paste. So ROS security strategy, we want to make it enforce. And the third one, or we can talk about the ROS security directory. This is the directory that we will be using today to store all of the security related files in. The last one, so remember I talked about there are different DDS vendor for ROS2. So the one that we'll be using today is, oh God, this is not copying, okay. If I can figure out how copy paste works here.
It's okay.
Okay, is the RMW implementation. RMW stands for ROS middleware. So the DDS vendor that we'll be using today is called FastRTPS. It's the default ROS2 DDS vendor. Okay, so at this point we've enabled security in our environment. And what I can show you is that, and how do we make sure that security is properly enabled? So if we go to, let's see, if we go to Turtlebot 3 workspace, so if we launch the same teleops node that Ryan just did, that controlled the Turtlebot to move forward, it should not work because I haven't given identity to any of the any of the nodes running on the system now. So
can you explain to us a little bit more what you mean by giving the robots an identity?
So we will be, in a minute, we'll be running a command that will generate security files. And that's giving the node an identity in the system.
Gotcha.
Yeah, we'll be using OpenSSL to create certificates for the node. But right now, I haven't done anything, but I've enabled security in our environment. So nothing should be able to run in our system now.
So now Bob should not be able to get hacked.
No.
All right.
Okay, so let's do Turtlebot 3 teleops. And I think there's the script.
You need to go back to Turtlebot 3 teleop, then script.
Is that?
Yeah,
Okay.
and you might run into an issue with this.
Because I need to also declare the model of Turtlebot I'm using today.
Yes.
Export. Looks like there's a T at the end.
And then it's
Also the command line thing.
the command line thing. Oh, the thing. Okay, so we made, that's fine. Turtle bot 3. Oh. Okay. Burger, and then let's launch the node. Again, this is the same node that Ryan just launched that made the Turtlebot move. Again, I haven't created any given any identities to any of the nodes, so no nodes should be allowed to run in our system now. Yeah. Okay. Exactly. So now you see in our security enabled environment, because again, I haven't given this node an identity, so this will be an unauthorized node. So before when it tries to launch in our system, it didn't work because the system couldn't find its identity. And this is, so sorry, I haven't introduced the service that actually does the discovery of identity for all the nodes running in the system. This is a DDS service plugin. It's called Authentication Plugin. It provides the means to verify identity of application that runs in our system. So for example, if a node is trying to publish to a topic, this service plugin will try to find if the node's secret has been established and if the established secret is valid. So in our case, it's not. Okay. So now,
So if we wanted to be able to have access to move the robot again, now that security is enabled, the next step is for us to create an identity, right?
yes, exactly.
And that's what you're going to show us how to do now?
Yes.
Awesome.
So I'm going to start with creating a Keystore. So Keystore is just a concept. It's just a folder that we will use to store all of our security related files. So the command that we'll be using, if you're running it on your machine, is ROS2 security create Keystore. And then I'm going to give the name of the Keystore demo keys. I'm not actually running the command right now because the laptop that I'm using to demo today is not connected to the internet, but this is what you would do. And then this will give you a directory. So this will give you something like this, demo keys, and you will be able to find it at where you've run the command.
So similar to how a second ago she mentioned that she had, prior to the episode, already pre-built Kalkan and gotten those things ready, she already got the keys and stuff done before, right?
Yes.
Okay.
Yes, exactly. Cool. And now I'm going to actually create keys. So again, because we're not connected to the internet, this is what you'll be running to create keys. So it's really easy. ROS2 has made it really easy. The command that we use is really self-explanatory. So we have the Keystore, and we're going to run create key, and we're going to give the name of the Keystore here, and then name of the node that we would like to give an identity to. So if we want to run the same teleops node that Brian just ran, we will do teleop keyboard. So again, we've created that, and so I'm commented out in my terminal. So if you run this in your ROS2 environment, now you should be able to see, demo keys. You should be able to see a new folder created in the demo keys Keystore, and then if you cd into that folder, you will be able to see all the certificates created for the teleops keyboard node. Okay, so that's all we need to do to enable security, and I'm going to so I actually need to go back to the old container.
So what are we looking for in this Docker container now?
So again, it's the same image that I'm using, but because we're running into that issue with the keyboard node not dead, so I created a new one, but all the security files I created is actually in the container that I stopped. So I want to show you guys that, actually this is the one that we're running. Okay, so this is the one. And let me go into the Docker container. Now, if I source ROS2 workspace, install local setup shell. Okay, so now let me show you really quick what the security files would look like. So I have the demo key, same demo key store here created. If I list out all the stuff in here, you see that I've created all these, I've given identities to all these nodes, the default XRC participant, the Turtlebot 3, and the Turtlebot 3 node. Okay, so and I've also created the security, an identity for the teleops keyboard node, so I'm gonna just move that into the Keystore. Okay, so now if I try to launch the teleops node, Turtlebot 3, teleops, cd into teleops, cd into script. I think I also need to do this for this environment. The turtle bot 3 model. Okay, so now you've actually tried to run the teleops node, Python 3. It works now, and oh, please work. Okay, it's actually moving.
All right.
So now,
So we created successfully an identity for Bob, and so now Bob was able to move again.
yes.
Awesome.
Yes, and now we can get to the other plugin, security plugin, DDS security plugin that I would like to show you guys. We're not going to be using it today, but just to give you an idea what it would look like and how that's useful for creating a secure environment. The other plugin is called Access Control plugin. It's also a DDS layer service plugin that it's trying to basically give permission to an authenticated node. Basically, it defines what a node can do in a system. So if I say, for example, if a node is trying to publish to a topic, it needs to go through the authentication service plugin. It needs to be given an identity. And now after that's passed, the service plugin, the access control plugin will try to read a configuration file and see if that node is permitted to publish to that topic. If it's not, then the message would not go through. And if it's permitted to do that, then yes, then the message would go through. So I will be writing a policy file, and just to give you guys an idea of what it would look like. So I'm going to create a policy.xml file, and so I'm going to write the headers first. Won't be too interesting to watch, but I'm trying to make it fast.
So it looks like today for what we're doing, we pretty much only needed to work with this XML policy document and then just the command line tools, right?
Sorry, I didn't pay attention to
No,
what you
it's
said.
okay. I shouldn't talk to you while you're coding at the same time. I was just saying to the audience that it looks like in order to secure their Turtlebot, if they wanted to try this out at home, really all they're working with is just the policy file, which is an XML file, and then the command line tools that you were working with today, right?
Yes, exactly. We want to make it really easy, really self-explanatory, so that robot developers out there can easily create their robot applications and not worry about security, or at least adding security layers in their ROS environment.
Awesome.
Yeah.
All right. So I'll let you continue on with your policy file.
It's not that interesting to watch, but point 1, I'm specifying the XML policy version.
So what you're going to see pretty soon, as Abby's typing away here, is she's going to be showing you a few basic tags that you need to include into your policy document. So she'll need to add tags related to creating different profiles and also creating different topics. As you may remember, we've been talking about this subscription platform, right? So in a second, she's going to go ahead and finish typing out and show us how you go ahead and, jot out which kind of topics you want and so forth.
Okay, so I'm going to create profiles. And these are all, you can find these all online. You don't have to remember the skeleton. This is just me showing you how this roughly looks like.
So just a quick Google, like maybe ROS2 policy document should be enough, right?
Yeah.
Awesome.
If not, then try to look for the examples in the sROS2 repository. They've got some really good examples that are easy to understand and will give you everything you need for creating access control in your system. So now I'm writing the skeleton here.
And if there's any of these things that you're curious about, or if earlier in the chat you weren't able to grab a couple links, just let us know in the chat what you want, and we'll shoot you over the links so you can check this stuff out yourself as well.
Okay, we should be writing just that policy. Okay, it's really hard to do it in Vim. Usually just do it in
It would be a lot more
Smart
fun if
editor.
it was in a normal IDE, huh?
Yeah. Okay, so this is roughly what the skeleton looks like. So you've got policy, and within policy you have profiles, and within profiles you can have different profile. So
you can nest profiles inside profiles.
Yes. Each profile defines the permissions that a node has in a security-enabled ROS2 environment. So if you have multiple node, you will be doing something like this, where this one is for node 1, this section here is for node 2. And now we'll be writing a security file for Turtlebot. So here in each profile, you would need to add 2 additional tags. For the first one is where the node's namespace is. The second one is the name of the node, and in our case will be the teleop keyboard node.
And this is matching what you had had earlier,
yes.
Right?
So this tells you that this section of the profile is defining the permissions the teleops keyboard node has in our system. And what will happen now is that we will say topic, and we'll say publish. If the node is allowed to publish 2 topics or not in our system, it will do something like this: allow, and we'll give it the name of a topic that it's allowed to publish to. So in our case, is command velocity. CMD velocity and /topic. Close the topic out, and then topic here. So now we've given the teleops keyboard node the permission to publish to the command velocity topic. If you have other topics that you would like this node to publish to, simply just add another topic here, and then the name of topic that it's allowed to publish to, and close that out with a //
So, quick question here, plain devil's advocate for the audience if they're new to this and they're wondering. I'm assuming that if I only had one topic, can I only have the CMD command velocity underneath the main topic tag?
Yeah.
Right? We wouldn't need to nest it under another one.
No, you wouldn't need to. If there's only just one, you can remove this one.
Awesome.
This is just showing you if you have more topics that you want to this node to publish to. Cool. And again, if you would like to do something like, you can do something like this, like a star. This is giving permission to this teleop keyboard node to publish to any node, any topics that you would like. So you can do something like this too. Now we can go to the same for pretty similar to publish.
To subscribe?
Subscribe, yeah. Subscribe. Right. Okay.
I know that when you're working on a laptop that's not your normal one, it's like the keyboard never quite adapts to your fingers.
Thank you for explaining that.
Yes, I know the pain. But no, thank you so much, Abby. This is really interesting.
Okay. So again, if we're giving the node the permission to publish in our ROS2 system, and again, this is the name of the node. Name of the topic, and again, topic, and then we're gonna close it out with topic here.
So what would be an example of something that a typical Turtlebot would need, a typical topic that they would subscribe to? What are a couple of examples that come to mind?
So we're doing a pretty stripped down version of the Turtlebot 3 example. If you follow Robotics' instructions exactly, you'll see a whole host of other topics on here giving you information like IMU data from the Turtlebot, or robot state publisher seeing the position of the joints and stuff. So you'll see a lot more information if you're running more nodes and more topics.
Oh, cool.
Awesome.
Yeah.
Okay.
All right.
So this would be something roughly, it would look roughly like this. So again, you've got the profile. Can people see my cursor? Okay.
I think so. It's blinking. Okay.
Okay.
People in the chat, can you see her cursor? It's very important.
So you've got profiles, and under profiles you have individual profile for each node, and within a profile, you define the namespace this node is in, and you define the name of the node, and things that this node is allowed to do in the system. So for example, if it's allowed to publish, yes, in our case, and it's allowed to publish to any topic that it wants. And for subscribe, is the node allowed to subscribe in our system? Yes, and right now it's allowed to subscribe to a topic name of the topic. Okay.
So it looks like we're getting confirmation from the audience, Abby, that they can see your cursor in the chat. Thank you. It looks like MazZL95. Thank you for your help today.
Okay, that's what it would roughly look like. Just to save it real quick if you need anything. Okay, so that's how you secure your Turtlebot.
Okay, so it looks like we covered a lot, but so I'm kind of feel like a little bit inundated here. But let's go ahead and maybe do like a little bit of a recap of what we were doing. And I think that we also wanted to briefly explain a little bit something related to the threat model. Does that sound accurate?
Yeah, so some more of the work our team's been doing recently. If this got you excited about robotic security and you want to learn more about security in ROS2, you can find this robotic system threat model that our team recently published on the ROS2 design page. It lists a lot more possible attacks against a robot and potential mitigations to defend against those attacks. Our Amazon's also leading the ROS2 security working group. We meet about every 2 weeks to every month. You can find announcements about when the next security working group will be on Discourse, and that's totally open to the public if you're interested in hearing more about the direction that ROS2 security is taking.
Okay, awesome. And so this isn't like an in-person meetup. This is something that you guys all dial into?
Yes, yeah.
Okay, awesome. So anywhere can join and just start hacking away?
Yep.
Or not hacking, helping people not hack, right? That was the whole point. Okay, so Abby, could you summarize for the audience what were the top components needed when you're thinking about security for robotic development?
Top components. So today we've shown DDS layer security plugin. These plugins are provided to you by different DDS vendors. And the two things that I've demonstrated today are authentication plugin and access control plugin. Authentication plugin is verifying an application's identity, and access control plugin is to decide what permission that an authenticated user node can do in a ROS2 system. Today's example is that Run has gained control to the network my Turtlebot is running on, and there may be different cases, but for today's case is that someone has already gained control to a network and they're able to launch a teleops node to control your robot. And what I've shown is that if you enable security in your ROS2 environment, you can prevent that from happening, for an unauthorized user from taking control over your robot.
Okay, awesome. Thank you so much for helping us with another recap. Quick question out of curiosity. I'm wondering now, you mentioned, Ryan, a second ago that there's other documentation there that they can see online about other typical threats that happen or different ways that people might try to hack your robot. Do you happen to know of any examples to share with the audience of typical things that happen?
Yeah, so some things that we could maybe do in a future episode is if people have physical access to your robot, protecting the integrity of your data. For example, this Turtlebot has a SD card in it that's running the entire operating system.
Oh, where is it?
Right here.
So in the second level?
Yeah, in the Raspberry Pi.
All right.
It's backwards for everyone.
I think maybe that will be
But
better.
with this tag running out here. But yeah, so if you had a robot, like this is of course not the most secure robot in the world, but if you have a robot running out there and someone can come in and just unplug an SD card that they have access to it, that's one threat. If they're able to launch a malicious node onto the Turtlebot, or even just like a misconfigured node that's able to eat up too much memory or too much CPU or write too much to disk, this could interfere with critical operations on your robot. And so other stuff you might want to consider for security is how you can sandbox your node running on the Raspberry Pi to stop it from consuming more resources or accessing resources that it shouldn't be able to. So there's a lot more to this than just network or security once someone has accessed the network.
Yeah, I guess hopefully you guys come back for another episode. Okay, is there something else that you wanted to add or share with the audience today?
Okay, I'm going a little off script right now. So I think Ryan and actually our team is going to publish a honeypot application. I think that will be really interesting to.
What's a honeypot application?
It's Ryan, why don't you explain what honeypot application is?
Way to throw him under the bus.
Yeah. No, I think it's really cool, and then we're gonna open source it too. So.
That's okay.
What we are looking at, and this has been discussed in some of the security working groups, is ways we can test the security of a robot specifically against some of those resource attacks we were talking about, and then demonstrating mitigation. So this is just further work in trying to validate the threats laid out in the model and validate the mitigations that we've proposed so that somebody can come and run some code on their robot and check, am I vulnerable to this setup, or have I properly configured my robot so that this isn't a concern for me? And yeah, there's lots of exciting work to be done in the security space in general.
I can see. I mean, I think that something that often happens in development work is we sometimes forget about accessibility and security, and we treat it as an add-on feature instead of being part of the original package from the get-go. So that's part of the reason why I was so excited for us to actually talk about security, because it's something that sometimes is overlooked. All right, it looks like we also have another question from the audience. Let's see, this is coming from, I hope I'm pronouncing this right, Shalene Saint. They're asking if data is encrypted at the robot level.
So I believe data is encrypted when it's going through the DDS layer and decrypted if the user is allowed to get that message.
Yeah, if that's what's meant by the robot level. Another thing is with that SD card, if somebody has physical access to the robot, is encrypting your hard disk so that nobody can come and just grab the data off of your robot or plug in their own. Actually, on this TurtleBot, we have installed, if you can see this blue flashing light.
Oh, maybe we switch it around for them.
It's here. Yeah.
Hopefully you can see it. I know that it's really inside
small.
there. In the middle of, it's just flashing bright blue.
But yeah, that's a TPM. I forget exactly what that stands for, but that's for storing cryptographic keys on your TurtleBot. And so what you can do is install, if you install that on your TurtleBot or whatever system, you can encrypt your file system, and then the keys are stored on that separate hard drive. And if you set it up correctly, then if anyone tries to tamper with it, it can brick or it will have encrypted the file system, so nobody can read the data, nobody can plug in a new drive to give different commands to your robot. So that's a way of securing a robot that's deployed in the field and encrypting data at the robot level.
Yeah. That's what I mean. No, you bring a good point, because so the thing about robotics is that it's interesting because it's not just software, but it's all hardware. So now you're also thinking about how can somebody try to hack the hardware itself, right? So there's like a lot to it. So what advice would you give to people like me who are new to this area? And security is not really like a 100 level subject, right? Like it's a little bit more like maybe 300, I would say. So if you're new to this, but you want to be a good robotic developer and think about security and learn about it, what would you say is the best documentation for them to get started on? Or one of them, if you have some ideas.
I think the threat model is a good one to start.
Threat model?
It's a bit hard, to digest, but it's I think it layouts all the possible attack that or most of the attack that we can think about, and solutions to mitigate the risks. So I think that's a good place to start.
Yeah, and I'd check out SROS 2 also for the DDS security layer.
And this is the tool that she was mentioning earlier, so not ROS2, the robotic programming language that we're working with, but SROS
2.
Yes.
All right.
Exactly.
Secure ROS 2.
Okay, cool. So I think that pretty much wraps up the content that we had for today. Thank you guys so much for tuning in and learning with us. Thank you so much, Ryan and Abby, for preparing this awesome demo. And thank you, Bob, for joining and being a great team player. So if you want to check out other videos that we're going to be making with TurtleBots, we're going to be doing another AWS RoboMaker episode on June 12th. And in that one, we're going to be showing you stuff with the gazebo simulation environment. So you'll get to see the actual little robot moving around in its own little apartment world, or maybe a bookstore, kind of depending on what we end up picking as the world environment. And that'll be here on Twitch, same at the Builder Show Wednesday at 1 p.m. So hopefully see you guys there. And thank you so much for joining. Yep. Bye.